Welcome to another Mathfolio video. This time we're taking a look at the Common Core Regents for August 2015. Okay, let's get started. It's part 1 questions. These are worth 2 credits each. Here's the first question. This one is talking about a parallelogram, and it must be a rectangle when it's, and then it gives us 4 options. So let's go through each of them. So parallelogram, usually we think of a parallelogram looking like this, where this and this are parallel, and this are parallel. Also, this is congruent to this, and this is congruent to that. So that's a parallelogram. But this is also a parallelogram, which is a rectangle. The only difference, or a little more criteria, one of the criteria that's really important, is that these are all 90, but there's something else as well. We should also think about the diagonals when we're thinking of classifying shapes. So when we think about these diagonals, they're not congruent, but they are bisected. So this piece here is the same as this piece here. This piece here is the same as this piece here. So they're bisected, but individually, this one right here is not congruent to this one right here. Whereas with a rectangle, these two diagonals, not only are they congruent, but they also bisect. But the key thing is that the diagonals are congruent. So let's take a look. Diagonals are perpendicular. Well, these aren't 90 degrees. Nope, that's not true. Diagonals are congruent. That is true. That is what happens when a parallelogram becomes a rectangle. The diagonals are congruent. Opposite sides are parallel. Well, that's true of both of these cases, so that's not the distinguishing feature. And number 4, opposite sides are congruent. Well, that's also true, but it's not the distinguishing feature of a rectangle versus a parallelogram. So number 2 is our answer for question number 1. Okie dokie. So this is number 2. It says if triangle A prime B prime C prime is the image of triangle ABC, under which transformation will the triangles not be congruent? So basically, when you think of transformations, you've got 4 options. 1, 2, 3, 4. You've got translations, which are slides. You've got reflections, which are flips. So you have something here, it becomes something here. You've got rotations, which are a turn. So you might have a shape and then you turn it and now it's facing this way. And then finally, you've got dilations. Now, dilations are stretching or shrinking of shapes. So basically, these first 3 are all what we called isometries. So isometries, or we can call them rigid motions, and they preserve distance. So they keep things being congruent, basically. Whereas a dilation is not a rigid motion. Now, it's really important that I explain these terms as we go through the test, because they might ask this question in a slightly different way using the term isometry or rigid motion or preserving distance. So basically, a reflection over the x-axis does preserve distance, so it does give you a congruent shape. Number 2, translation, that is a rigid motion, so it keeps the shape congruent. Dilation, that's the one. A dilation with a scale factor of 2. The only time a dilation would give you a congruent shape is if the scale factor k was 1, and then no change would happen. It would just stay the same. Rotation, that just keeps the shape looking the same. It's just turned, but it's all the same size and the same angles. So number 3 is the answer to question 2. Okay, so here is question number 3. It says if the rectangle below is continuously rotated around side W, which solid figure is formed? So let's draw a line, a red line right here. This is W, and it's saying rotate this shape around it. So I'm going to have to do a little bit of sketching right now. So we're basically rotating this entire thing around. So this right here is going to come all the way out and go around. This thing here is going to go all the way out. Really, that's the edge of it right there, and then it's going to go all the way back. And if it does it really fast, this whole shape here, you're going to notice that it in fact creates a cylinder. So I don't know if you can see it here. I know it's a wonderful drawing, but it's going to create a cylinder. So that is our answer. Number 4 is the solid that is created. Okay. Question number 4. Which expression is always equivalent to sine x when x is between 0 and 90? So then we have a few options down here. Like there's a couple of ways to do this. The quickest one is just to plug in. So basically, let's say that x is 20. I don't know. I don't think 20 is going to cause us a problem if we just pretend x is 20. Here we're doing 90 minus 20. So this option would end up being cos of 70. This option here would be cos of 45 minus a 20. So we're just plugging in this 20 into each of them. So 45 minus 20 is 25. Number 3 is cos of 2x. So really we're doing the cos of 2 times 20, which is 40. And then we're doing the cos of 20. Now I'm going to change color. I'm going to make it green. And now the strategy is just to find out what is the sine of x when x is 20. So what's the value of this? Well, I'm going to just take a calculator right now, clear it. Sine 20 gives me an answer of 0.34 and change. So this is sine 20 equals this. So I need to figure out which other one equals 0.34 and change. So if I do cosine of 70, that gives me 0.34 and change, 0.34. So could that be our answer? Maybe. So let me check a couple of the other ones. So if I do cos of 25, I get 0.906 and change. If I do cos of 40, which is option number 3, I get 0.766, and that decimal goes on as well. And then finally, number 4, cos of 20. Cos 20 equals, I get 0.9397 and change. So basically, looking at all of these ones, number 1, we were correct from the get-go. So the expression that is always equivalent to this is cos of 90 minus x. And so that is our answer for number 4. Okay, question number 5. It says, in the diagram below, a square is graphed on the coordinate plane. Okay, there's the square. A reflection over which line does not. So I'm going to circle the part where it says not, because that's super important. Does not carry the square onto itself. So a couple of these answers have lines. So the first one is x equals 5. So let's draw that line. We're going to go to where x is 5. 1, 2, 3, 4, 5. So this is 5 on the x-axis. And so the line x equals 5 is right here. This is x equals 5. And I'm going to put little arrows on there. This is really good practice. So I'm also going to write next to it. Should always label this x equals 5. So if I reflect over this line, this square is going to look something like this. And really it goes over 6, so it's going to go just off, and then it's going to go back down. So this reflection did not carry itself onto itself, so our answer is 1. Now, just to check a few of the others, let's just take a look. Y equals 2. So if I go to where y is 2 and draw a line, this is the equation y equals 2. And maybe you can see it that if you reflect these points over this line, this one's going to go up, this one's going to go down, but they do land on themselves. These two are going to switch places, but the square is right exactly where it is. Another one, let me choose a pink line. The line y equals x looks like this. This is the line y equals x. So let's write this, y equals x. And you know what? I should also really write what this one was, which is y equals 2. And so, I'm not sure if you can see this. I'm going to go back to pink. But basically, when you have a point on this line and you reflect it over the line, it stays the same. Same with this point. Now, this point here, bottom right, becomes this one. And this one trades places as well. So it does carry the shape onto itself. So this one carries the shape and this one carries the shape. For number 4, just to very quickly do this, to get y on its own, let's minus the x. This is always a good strategy when you are trying to figure out the equation of a line. And so when x is 0, You could even do a little table, x and y. When x is 0, y is 4, and when x is 4, plug it in, y is 0. So these are a couple of points. I'm going to choose a blue marker right now. We could label these points 0 and then 4, which is 1, 2, 3, 4, which is right here. And then the other point is 4, 1, 2, 3, 4, comma 0. And so the line that we're dealing with here goes something like this. It goes through those 2 points. And maybe you can see that this is going to do pretty much the same as the line y equals x. It makes all the points trade places. The equation is y equals negative x plus 4. But basically this point here jumps to this one. This point here stays the same, and so does this one. So the square looks the same in all cases apart from number 1. So we had our answer straight away. Answer 1 for number 5 is correct. Alright, question number 6. Here it says the image of ABC after a dilation of scale factor k centered at point A is A to D to E. So basically it stretched the shape out. And it says, as shown in the diagram, which statement is always true? Well, when you do a dilation, one thing to remember is that you end up with similar shapes or similar figures. And also similar shapes have congruent angles and sides that are proportional. So you should definitely remember these couple of things. So if I split these triangles, maybe it's going to help me, but this is ABC, and the other triangle is bigger. This one is ADE, but the thing to remember is these angles are the same, A and A, and also B is the same angle as angle D, and also C is the same as angle E. It says which statement is always true? Well, let's take a look. Say scale factor of k, so we don't know that we doubled it, but here it's saying 2 times AB, 2 times this distance is AD. Well, we don't know that's true unless the scale factor is 2. Next, AD, A to D, is perpendicular to D to E. Well, that would be true if this is 90 degrees, but we don't know it. Next, AC, A through C is right here, equals C through E. Well, again, we don't know that unless we're told the scale factor is 2. So it must be the last one, but let's take a look at what it's saying. Change color to red. It's saying that B through C is parallel, rather, these two lines mean parallel, is parallel to D through E. Now this would be correct because this here is congruent to this here, as we see over here. B and D are both the same angles. So if those are the same angles, then those are actually corresponding angles in a situation where we have 2 parallel lines cut by a transversal. So if they're congruent, it means they're parallel. And if we knew they were parallel, we would know that these are congruent. So number 4 is our answer. Okay, this is question number 7. It's saying a sequence of transformations maps rectangle ABCD onto A double prime, B double prime, C double prime, D double prime. So this somehow moves down here, and then this somehow moves over here, and it looks like there's some turning of this shape as well. So we need to take a look at this order, 1 to 2 to 3. It says which sequence of transformations maps ABCD onto A prime, B prime, C prime, D prime, and then also those primes onto the double primes. So let's see, it looks like A is at the top and D is at the bottom, and that's not the case here. It's switched. D is now at the top and A is at the bottom. So orientation wasn't preserved, which in this case is down to a reflection. So the first thing that happens is a reflection. So I'm going to write that here, reflect. And so the answer must either be 1 or 2. So now I'm comparing these two answers. I've got rotation versus translation. Well, to take number 2 to number 3, a translation would keep orientation. And this has obviously done some turning. So it looks like this is a rotation around the origin and maybe even 90 degrees. But the second thing is a rotation. So number 1 is our answer for question 7. Okay, here's number 8. Alright, so we're told to label a few things here in the diagram of parallelogram FRED. So if F to R to E to D is parallelogram, we know a few things. We know these two are parallel, these two are parallel, we know that. We know this is congruent to this, and these two are congruent. We also know this angle here is congruent to its opposite, as is E and F, both congruent. Now, it also tells us ED is extended to A, so E to D is extended to A, and also AF is drawn such that, this is important, AF is drawn such that AF, A to F, is congruent to D to F. Well, D to F already has these two markings, so I guess we can say A to F is congruent to D to F, and don't forget, we also know that's congruent to R to E, or ER, however you want to say it. So now that we know all of this, we know that F to A to D is in fact a isosceles triangle. Two sides are the same. So therefore this right here, let me do 3 lines, must be congruent to these three arcs. So these angles are identical. So anyways, let's keep reading. It says the measure of angle R is 124. 124 degrees. And it says, what's the measure of angle AFD? So A to F to D. So that's right here. I'm going to put a big dot. Wants to know that angle. So I'm going to change up the color because this is where we do more than just label. So far we've labeled everything and we've written what we know. But if this is 124 here, we can also move it to 124 here. Now, both sides of this angle, they make a straight line. So therefore, to find this angle D, we would do our 180 degrees, which is a straight line, and minus the 124 degrees, and that gives us an answer of 56 degrees. So we now know this is 56. And if that's 56, so is this. So the top angle here is, well, first of all, let's add the two 56s. So that gives us 112. And to find that top angle, we do 180 minus the 112. And so that gives us an answer of 68 degrees. So FAD is 60, actually not FAD, it's A to F to D. It's right up here. It's the vertex angle of an isosceles triangle. And we did this because of knowing parallelogram, opposite angles are congruent, knowing about a linear pair being supplementary, adding to 180, knowing that this is isosceles, which has two congruent base angles, and then knowing that the sum of degrees, sum of angles in a triangle add up to 180 as well. So we used all of those facts. So that was question number 8. Okay, here's 9. So in this question, we are told that this is the equation of a circle, and the length of the radius is question mark. We're trying to find that. Well, you know, hopefully we remember the equation of a circle looks like this. X minus h squared plus y minus k squared, and that equals r squared. So if we can't make this look like this, we have to make this look like this. So you've got to go one way or the other. So as we take a look here, maybe, just maybe, we could take this x squared plus 4x and do x plus 2. Now if we square that, that's going to give us x squared plus 2x plus 2x, which is plus 4x, and then plus 4. Well, got to be a little careful, because if we trade this out for this, we've now got this extra plus 4, so we've got to add 4 to the other side to make what we did allowable. The next thing, we've got y squared minus 6y, so that we could write as y minus 3 and squared, and that's going to give us y squared minus 3y, which is a minus 6y, which is what we need. But now we've got negative 3 times negative 3, which is plus 9. So if we're converting this to this, and we've got an extra plus 9, we've got to add the 9 over here. So far so good. Now this minus 12, let's just ship it to the other side. Now we've got to do that by doing a math operation, so we're going to add 12. If we add 12 to both sides, this gives us equals 4 plus 9 plus 12, so that's 13 plus 12, which is 13 plus 12 is 25. So when we're asked for the radius, well, this here is equivalent of r squared. So if r squared equals 25, when you square root both, you get r equals 5. And so that's the radius, number 3 for number 9. Okay, question 10. So given mn shown below, with m being negative 6, 1 and n being 3, negative 5, what is an equation of a line that passes through this point and is parallel? Wow. Okay, so first of all, let's write the basic general formula for a linear equation, which is y equals mx plus b. This is your y-intercept. This is your slope. Now for this line segment mn, we could find the slope. The slope is the change in y, so negative 5 minus 1 all over the change in x. So 3 minus negative 6. 3 minus negative 6. So this becomes negative 6 all over 9, which is negative 2 over 3. So it says, what's the equation of a line that passes through here and is parallel to mn? Well, this is the slope of mn. And we could complete this equation and get the b and plug it all together, but basically this is your slope. This is the slope. And so we can kind of see how it goes down 2, 1, 2, and goes across 3. So if this is a slope of this, a slope of something parallel, slope of something parallel is going to be exactly the same, negative 2 over 3. So the next step is to consider that this line has to go through P. Now P is at 6, 1. So what we're going to do is we're going to take our y equals negative 2 over 3x plus b. We need to find the b, and then we know either it's 5 or it's negative 3. So to find b, we're going to plug this in. Now you've got to be careful. The y value is 1, so 1 equals negative 2 over 3 times by 6 plus b. When we do the math work here, negative 2 times 6 is negative 12 all over 3 plus b. So this is really negative 4 plus b. And then to get the b on its own, we're going to add 4, add 4. So b equals 5. And so we now know that y equals negative 2/3 x plus 5. And so answer 1 is our answer for question number 10. Okay, so this is question 11. It says Linda is designing a circular piece of stained glass. So, all right, she's starting with a circular piece of stained glass. All right, and it says that it has a diameter of 7 inches. So even though it tells us 7, I could label it, I guess. The whole thing from side to side, from here to here, is 7 inches. But maybe more useful is going to be the radius, which is 1/2 of this. So that's 3.5 inches is the radius. Now, next thing, it says she is going, right here, she is going to sketch a square inside the circular region. There's going to be some kind of a square in there. It says to the nearest 1/10 of an inch, the largest possible length of the side of a square is. So the biggest square, well, you know, this 3.5, this is important. So what we can do is we could draw the square so it's just touching the edges of the circle, so it's completely inscribed. Now, why this is pretty useful for us is that now we have half of the diagonal of the square. We know it's 3.5. So they want to know what is the largest possible length of the side of a square. So let me call it x. And all of these are x. So our whole mission right now is find x. Now this is 3.5, which we already have. 3.5. And also this is 3.5. And this is 90 degrees. So if you look very carefully here, I'm going to draw this in pink, but this is a right triangle. 3.5, 3.5, x, which is what we need, and this is 90 degrees because the diagonals of a square are perpendicular bisectors. So all of a sudden, we could use the special ratios for a triangle here because we have two sides that are the same, or we could just do Pythagorean theorem. So 3.5 squared plus 3.5 squared equals x squared. And so I'm just going to plug all of that in a calculator. And in fact, I'm going to do 3.5 squared equals, and then I'm going to times it by 2 because we've got 2 of them. So that gives me 24.5. So 24.5 equals x squared. So when I square root 24.5, the answer I get is 4.95. So let's see, x equals 4.9, and really it's 94974, and it goes on a little more as well. So when we're looking for our answer to the nearest tenth of an inch, well, tenth is right here. That 4's not going to raise the score. So the saying goes 5 or more raise the score, so that 9 would increase, or 4 or less, let it rest. So this final answer is 4.9. Okay, here's number 12. This is an interesting one. In the diagram below, AC, A to C is tangent to circle O at A. So if it's tangent and that's a radius, this must be 90. And the same over here, those must be 90 degrees. And then we're also told that OP intersects, O to P intersects at AC at B. So we know that's where it intersects. And OA is 4, and also AB is 5, and PC is 10. So everything else is labeled. So when we look at this, we know, well, this angle is the same as this angle. We also know that this angle here is the same as this angle because they're vertical angles. So angle, angle. So already we know that these two triangles that we see are similar by angle, angle postula. So that means all sides are in the same ratio. So the question is asking us for BC, which is right here, and OA, which is 4, corresponds with CP, which is 10, and that matches how A to B, which is between the 90 and the vertical angle, and the value is 5, matches with the same side over here, which is in fact BC, the thing that we need, the length of BC. And we know it has to match this side because it's between the two angles that we've already established. And here it's between the two angles as well. So to get BC on its own, cross multiply. So this times this gives you 4BC. This times this gives you 50. To get BC on its own, divide by the 4. So BC equals 12.5. We can check this. If you times this by 4, you double it, and then double the result, you're going to get back to the 50. So this is our answer number 3. Okay, question 13. Okay, here in the diagram below, which single transformation was used to map triangle A onto triangle B? So if you look closely, this is 2 over and 1 up, and that point became this one. 2 up and 1 over. So we could look at the other points as well. 2 over and 4 up, 2 up and 2 over and 3 up, 1, 2, 3, and then over here we've gone 2 up and 3 over. But basically we have rotated counterclockwise, and the number of degrees is 90 degrees, because here we were heading out to the east, here we're heading out to the north. So that's one of the ways. So when we take a look through this, the only answer is this one, rotation. So perhaps a little easier. We didn't need to say about the center. We didn't need to say a certain number of degrees, but 13, number 2 is the answer. Okay, here's 14. In the diagram below, DEF is the image, D to E to F is the image of ABC. So let me just line that up, DEF, ABC, after a rotation of 180 degrees, and then a dilation where AB equals 3, BC equals 5.5, and AC equals 4.5. And then also these other values. So everything else here is labeled. They've told us it again, but everything's labeled. So basically it was a rotation and a dilation. So a rotation keeps everything congruent. This just basically turned upside down, and then the dilation in this case has stretched it. So 3 became 6, 4.5 became 9, and also this one, let me put it in a cloud, became this one. So it looks like everything multiplied by 2, because I see the connection. This multiplied by 2, this one multiplied by 2, this one multiplied by 2. So which relationship must also always be true? Well, what happened to the angles? All the angles stayed the same. A and D are the same. And then E and B, so E is here, B is here, E and B stayed the same. And then F and C, 2, 3, 1, 2, 3, also stayed the same. So measure of angle A over D, they are corresponding angles A over D. So that should leave us with a ratio of 1 over 1, which is 1. So this one's not true. It's looking for must always be true. So let's check. C to F. C does correspond with F, so again it should be 1 to 1. So it's not that. Next one, measure of angle A compares with the measure of angle C. So that's your 1 stroke comparing with your 3 strokes. Does that equal measure of angle F, which is 3 strokes, all over the measure of angle D, which is 1? Well, that's also not true. So because they're turned upside down, it doesn't have to be true unless all these angles are the same. So our answer must be the last one. Let's just check it out. Measure of angle B. Let me change color for this. Go for a green. Measure of angle B, which is right here, divided by measure of angle E. Now keep in mind that B and E are corresponding, because that's B. So this should give you a fraction that is ends up being 1. Whatever's on top is the same as whatever's on bottom. And then over here, if this is worth 1, this also has to be worth 1. So measure of angle C, which is here with the 3 lines, divided by the measure of angle F, which also has these 3 lines. So 1 equals 1. That is our answer. Answer number 4 for question 14. Okay, here's 15. So here we've got a quadrilateral inscribed inside of a circle. It says it's quadrilateral. We know nothing other than these 2 angles. So the trick here is that opposite angles are supplementary. So if this is 110, this has to be 70 degrees to make it 180 total. And if that's 72, this has to be 180 degrees to make it 180. So what is the measure of angle A to D to C? So A to D to C, we pretty much already did it. So the answer is 108 degrees. And the math is, I guess, 180 minus 72, gives you the 108. That is the correct answer, number 15. Okay, 16 is next. Now in this problem, it says a hemispherical. So this word here means half a sphere. A sphere is like this, but a hemispherical is talking about cutting the shape in half, and you end up with like a bowl type shape. Okay, so a hemispherical tank is filled with water and has a diameter of 10. So diameter of 10 is useful, but really I'm going to focus on radius. So that would be half of that. That's be 5. So this is 5 feet. The weight of it is 62.4 pounds per cubic foot. So not inches, but foot. Cubic feet rather. And so let's find the volume of this hemisphere right now. I'm going to just change the color to blue. So volume of the sphere is 4/3 pi r cubed. Now we don't want the entire thing. We just want, in fact, half of it. So to find the volume of half of this thing, I'm going to take the volume of all of it and then divide by 2, which is the same as multiplying by 1/2. So the volume of the hemisphere now becomes 1/2 times 4/3 times pi times the radius, which is 5 cubed. And so let's figure out that number. So I'm just going to plug all of this stuff in right now. So 0.5, which is the half, times by 4/3 in parentheses, times by pi, times by 5 to the 3rd power. So that gives me an answer of 261.799 and change. Now it wants to know what is the weight to the nearest pound. So I'm going to circle that. What is the weight of the water? So we take this volume, and then what we've got to do is we have to multiply it by this 62.4. 62.4 is up here, and that's how much it weighs per 1 cubic foot. So if we've got 261.799 cubic feet, we have to multiply that by the 62.4. So I'm not going to actually use the 0.799 number. I'm going to use the full number on my calculator. For accuracy, do times by 62.4. That gives me an answer of 16336.2818, and that would be pounds for the total weight. I'm looking for my answer. It says to the nearest pound, so this is going to be at 16,336. Okay, question 17. Okay, so it's another one of these two similar triangles. So let's take a look. I'm going to separate these triangles because sometimes it's easier. So this is A, D, and E. And the other triangle is A to B to C. It says which measurements are justified by this similarity. So if they're similar, then we know that the sequence of these letters tell us, it unlocks the secret between which sides are corresponding. So AB, which is right here, corresponds to AD. Now I'm not going to say that they're the same because they're really not, but they are corresponding. So I'm just going to do a dotted line right here, and then BC corresponds with DE. So BC corresponds with DE, and then that means that a third one must correspond with this one. But keep in mind, the sides are not congruent, the sides are just in proportion. So basically we're told if AD is 3, so let's run through some of these options. So if AD is 3 and AB is 6, then it looks like what's going on is times 2. Let's see if that keeps working. AE is 4 and AC is 12. So now we've got a question. 3 to 6 is times 2, but that didn't work here. Here we're timesing by 3. So that isn't correct because they should be in the same proportion. So that is not true. So let's try the next one. I'm going to change the color, go to red here. So here it says AD is 5 and AB is 8. AB is 8. And then we'll also know AE is 7. And then also AC is 10. So here we can't see exactly how we multiply, but we can do 5 compares with 8 as 7 compares with 10. And we're going to check, are these two fractions equal? If they are equal, then the sides are in the same proportion. If we cross multiply to check this out, we've got 5 tens, 50. And then 8 times 7, 8 sevens are going to be 56. So these two numbers are not congruent, they're not equal, so therefore this proportion is not true. So now we can cancel answer number 2. All right, next if we take a look, I'm gonna separate these just so it's a little clearer again. A, D, E, and then over here we got the bigger one, which is A, B, C. So here it says AD is 3, so let's put a 3 there, and then AB is 9. Okay, so this looks like times 3. And then we know AE is 5 and AC is 10. Well, that doesn't work. 5 times 3 is not 10, so it's not this one. So therefore it must be option number 4. But let's just do the work to make sure. Go choose pink. So we've got AD is 2 and AB is 6. And then we've got AE is 5 and AC is 15. Okay, so 2 times 3 does give you 6, and 5 times 3 does give you 15. And you could also check this in the same way. 2 over 6, does it equal 5 over 15? And both of these fractions simplify to 1/3, so 1/3 equals 1/3. Number 4 is your answer. Okay, question number 18 here, triangle FGH. FGH is inscribed in circle O. So this is the name of the circle, circle O. So we know that FG is in fact the diameter. So if FG is the diameter, this equals this. Those are the radii, and also this that's labeled 6 must be a radius. It goes from the center to point H on the outside. So each of these must be also 6. So something else that we know about this as well, and that if this is 6 and this is 6, then this is an isosceles. These two angles are the same. And over here, these two angles must also equal each other as well. So we know that to be true. So anyways, what else do we know? So OH is 6. FH and OG. FH is congruent to OG. So we do know that. FH, which is right here, I'm going to put 2 lines, is congruent to OG. And OG is 6. So if this is congruent to that 6, it means that this is also 6. So these 3 angles from F to O to H, all 3 of these angles are the same. And for all 3 of these angles to be the same, this must be an equilateral triangle, which means each of these angles is 60 degrees. And each side length we already know is 666. So it says, what is the area of the sector formed by angle FOH? So I'm going to shade this in light orange. FOH is here. And it wants to know not just this triangle, but the sector which includes this segment up at the top. It wants to know what is the area of this. So to find the area of this, we take the area of the whole circle, which is pi r squared, and we times it by the angle fraction. Well, we know this is equilateral, so this middle angle must be 60 degrees out of a total of 360. So when we plug in the radius, 6, we get pi 6 squared times by, now 6 over 36 simplifies. 60 over 360 simplifies to 6 over 36. But that goes even a little further to 1 over 6. So we end up with pi times 36 times 1 over 6. 1 over 6 times 36 is 6, so the answer is 6 pi. And that's our answer. That's number 18. Alright, so this is question number 19. In this question, we are told that AB and CD intersect at E. So that's really just telling us about this point right here. That's the point of intersection. We're also told that A to C, AC segment, is parallel to BD. And so that now tells us a whole bunch of things. 2 parallel lines with AB as the transversal means that this is congruent to this because of alternate interior angles of being congruent, and also angle D and angle C are the same because those are alternate interior as well. And we also know these angles in the middle, let me do 3 little arcs, must be the same because they are vertical angles. So we know by angle that these 2 triangles are similar, and angle is one of the postulates for similarity. But we're also told it down here. We're told given that triangle AEC is similar to BED, which equation is true? So one really important thing is to always start at the same triangle. So I'm numbering them both. Triangle 1 is the big one at the top, triangle 2 is at the bottom. So the first statement, and it's trying to have us check which one is always true, is CE, which is right here. CE is here, and that relates to DE, which it does. CE goes between 2 and 3 strokes, and DE goes between 2 and 3 strokes. So that's going from 1 to 2, and then it says equals EB to EA. Now we switched it. Now we're going from 2 to 1, so that is not the case. We've got to start from the same triangle each time. So number 2, let me change color pen for this. Number 2 says AE, which is right here. AE matches with BE, which is true, and now we've gone from 1 to 2. As AC is right here, matches with DB, so again 1 to 2. So it looks like this might be our answer. Let's just check the others though. Changing to green pen for this one for 3. It says EC, which is right here, CC, matches with AE. Okay, well, now we're going two sides of the same triangle, which is possible. This is one way of thinking it through. So CE to AE matches BE. BE, well, BE is between the 3 and the 2, and the first one, CE or EC, is between the 3 and the 2 to the 1 and 3. So okay, so then BE over ED. BE over ED. So let's get this right. It says AE, let's go right back. This is a little confusing, so let's start over. So EC, which is right here, EC, which is right here, they're taking EC and they're putting it over AE. So they're putting, this is the first thing they're doing, and then they're doing this. So EC is here, between 2 and 3 strokes, over 1 and 3, equals BE, which is between the 3 and the 1 stroke. So you see that BE is between the 3 and the 1, so BE is not actually a partner with EC, so it's not this one. So I don't know if you can see this, but it's got to be, the side has to be between the number of, matching by the same number of arcs. So these arcs are 3 here and 3 there, so really BE really matches with AE, and so that's why it's not number 3. Okay, I'm changing to orange for the last one. E to D, which is right here. E to D looks more like yellow. E to D matches with E to C, which they do. It's between 2 and 3 strokes. Those are corresponding, and this is from triangle 2 to triangle 1. And the last one, AC matches with BD, which it does, but this time we've gone from triangle 1 to 2, so that's not correct. We can't switch them up like that. So therefore our answer is number 2 for question 19. Alrighty. So here's question 20. Bunch of words. A triangle is dilated with a scale factor of 3 with the center of dilation at the origin. Alright, so let's just see what that could look like. Got some triangle, dilate it with a scale factor of 3, makes it look 3 times bigger, and the distance here gets 3 times further away. Okay, so K equals 3. That's a scale factor. It says which statement is true. So let's go through them. The area of the image is 9 times the area of the original triangle. Well, I think that might be true, because if you take something with a side length ratio of 1 to 3, then the ratio of sides is 1 unit to 3 unit. But when you look at the area ratio, it's not 1 to 3. In fact, instead of being 1 to 3, it's 1 squared to 3 squared, which gives us 1 to 9. So therefore, if it says the area of the image, the new shape, is 9 times the area of the original triangle, that is correct. It is true. So let's just try and rule out some of the others. Number 2, the perimeter of the image is 9 times the perimeter of the original. Well, perimeter is a type of side length, so the side length is just 3 times, whereas the area is 9 times because of this ratio. So it's not that one. Okay, number 3, the slope of any side of the image is 3 times the slope of the corresponding image. Well, that's not true. The slopes are going to end up being the same, so it's not number 3 either. And then number 4, the measure of each angle in the image is 3 times the measure of the corresponding angle in the original image, in the original triangle. Well, that's not true. Angles don't change with scale factor with dilation. Angles stay the same. So it's not this one. So we were right. Number 1 is the answer, and it's all to do with these ratios. And if for some reason we were comparing volume of some shape, the volume ratio, if we start with a 1 to 3 for side length, we would cube them both, so this would become a 1 to 27 ratio between the volumes of the two shapes. So that was number 20. Here's number 21. Here we're talking about a pyramid of Giza. It says it has a regular, it has a square base. And so this is how we draw a pyramid. We draw the square, and then we draw a point in the sky, and then we come to each and every point here as well. So it says the volume of this shape is 2592276, and it says, and a height of 146.5. So that height is from the very peak, it's really called the altitude, all the way down. So this is 146.5 meters. And it says what was one length of the side of its base to the nearest meter. So let's call it x. This is also x. So we know for this shape volume equals 1/3 base area times height. So now we've got 2592276, which is the volume, which is plugging in, equals 1/3 times base area, which is, well, it's a square, so it's x squared, x times x, times height, which is 146.5. So to start to undo this, we're going to times both sides by 3. So if I times this by 3, that 3 kills this 1/3. And then we must remember to times the other side by 3. And then to get rid of this 146.5, we're going to divide by 146.5. 6.5. And so now we would get x squared equals, so now I'm just going to throw all of this into the calculator. So 3 times 2592276, and take that number, divide by 146.5. So at the moment I've got x squared equals 53084.15, and there's more numbers as well. So now I've got to square root both of those. So second function square root, second function negative, which drops in the answer. So that gives me an x value of 230.39. So 39 would become 4, but it does say to the nearest meter. So therefore x would equal 230 meters. That would be my answer for question number 21. 230 is option number 4. Okay, I'm getting there. Here's number 22. A quadrilateral with vertices of these. So, you know, I'm going to basically try and plot it. Sometimes it helps. There's always some graph paper towards the end of the test that you can use for scrap. Take down some notes. So we've got -3, -3, 1, which is right here. And then we've got 0,3. 0,3 is right there. Then we've got 5,2. 1, 2, 3, 4, 5,2. And then finally we've got -1, -2. So -1, -2, right here. So I've just sketched this. It might look like a whatever, a rectangle or a trapezoid. We really don't know at this point. So we can't assume things that look like right angles are right angles. We should also be using a ruler, so definitely don't be as wobbly as I am. So it says, what type of quadrilateral is this? Well, for it to be a square, it would need 4 90-degree angles. For it to be trapezoid, it would need 1 pair of parallel sides. For it to be a rectangle, it needs 2 pairs of congruent sides and all 90s. And for it to be a rhombus, it needs all sides to be the same. And also other things like diagonals are perpendicular as well. So let's start out by giving these some letters. So A, B, C, D. So let's try and find the slope of each. So the slope of AB, BC, CD, AD. So we're going to try and find the slope of each of these. So for AB, A to B, we've got a rise of, so it goes from 1 to 3. So it's a rise of 2 over a run of 3, 2/3. For BC, we've got a rise of -1 because it drops down over a run of 5. For CD, C to D, we've got, let's think what goes on. the rise is from -2 to 2, which is 4, all over a run of -1 to 5, which is 6. And then for AD, we've got a rise of -3, all over a run of 2. So the -1/5 and the -3 over 2, the BC and the AD, they have no type of relationship for slope. However, BC and CD, actually not BC, however, AB and CD are equivalent, because 4/3 is the same as 4/6 is the same as 2/3, and if you look carefully, those two have the same slope, meaning that they are in fact parallel. So therefore we know that it has one pair of parallel sides, so it's number 4, a trapezoid. That's our answer. Okay, here's 23. It says in the diagram below, triangle ABE is the image. ABE is the image after a dilation centered at the origin. And it's the image of ACD, so it shrunk, it got smaller. So therefore we know that K, let me just bring up a sheet here, we know that K must be less than 1, but must also be greater than 0, but basically K is a fraction that's less than 1. That's very important. It says the coordinates of the vertices are 0, 0, which we see here, also 3, 0, which is there. D is at 0, 6, okay, and then E is at 0, 4, and C is at 4.5, 0. All right, so it says the ratio of the lengths of BE, B to E, to CD. So because it's a dilation, which we were told that from the very start, because it's a dilation, the angles are all the same, but the sides are proportional. So whatever the scale factor was, whatever it shrunk it by, it did the same to all of them. So the ratio of BE to CD is going to be the same as the ratio of, let's just think, so BE to CD, right? BE is the smaller one. So it's going to be the same as the ratio of AE to AD, because all sides have the same ratio. So if we're dealing with AE over AD, it's just the same as doing BE over CD. Just easier numbers. So in this case, AE is going to be 1, 2, 3, 4 steps up, and AD is going to be 6 steps up. So the ratio of BE to CD is going to be 4 over 6, which could simplify to 2/3. So 2/3 is our answer for the ratio of lengths BE to CD. Okay, now 24, this is the last question from the multiple choice. It tells us a line. It says it's transformed by a dilation with a scale factor of 2. So here's a shortcut. If you're given this line, 3x minus 1, and you perform a dilation on it, one thing that happens is that if it was centered at the origin, then the slope would stay the same and everything else would increase by a factor of 2. But I'm also noticing that the dilation with a scale factor of 2 and centered at 3,8. Just got to be a little careful here. So I'm going to map out my coordinates, my quadrants. So I'm going a little quick before. I might have made a mistake here. So let me just plot this line real quick. We're given a few points. We're given, well, first of all, it's centered at 3,8. So 3,8 is the center of the dilation. We're given the first line, which is y equals 3x minus 1. So when x equals 0, then y equals -1. So 0, -1. It's important, 0, -1. And also when x equals, let's just say 3, and 3 times 3 minus 1, 3 times 3 minus 1, then y is going to equal 8. So 3, 8 is also here. So therefore, that 3, 8 is on the line, and that is precisely, oops, screw that up a little. It's on the line, and that's precisely where the point of the center of the dilation is. So this line is going to stretch away from this point. So the line itself is going to look exactly the same. Just points that are close get 3 times further away. But because the center of this dilation is on the line, we know that the new line is going to look exactly the same because it goes on forever and ever anyways. So therefore, that's our answer. Y equals 3x minus 1. That's our answer for question number 24. Okay, so this is question number 25. This is the first question in part 2. So non-multiple choice, you've got to be a little careful. It says a wooden cube. So I'm going to stop reading right now. Once we know it's a wooden cube, I'm going to draw it. Okay, so draw a square, draw another square behind it, and just connect them all up. Has an edge length of 6. This is 6, 6, and 6, and a mass of 137.8 grams. It says determine the density of the cube to the nearest thousandth. So density equals the mass or the weight over the volume. Okay, so density equals mass over volume. So density equals mass over volume. So the mass is 137.8. Density equals mass all over volume. The volume of this thing is 6 times 6 times 6. Because a cube, the volume is just length times width times height. It's just exactly the same as a rectangular prism. So 137.8 divided by 6 to the third power gives me an answer of 0. And it does say the nearest thousandth up here, so I should always circle that. So the density equals 0.638, which I'm noticing is right here. So it's ash, and it says state which type of wood the cube is made of using this. If we don't do this, we are losing 1 out of 2 points. So we found the density. Could also put units in there, which is grams per centimeter cubed. And so that's probably for 1 point with the work. And then we've got to say the type of wood is ash. And that's it. Question number 25. Okay, here's 26. So it says construct an equilateral triangle inscribed in circle T shown below. Leave all construction marks. So there's always several ways to do this. I'm going to do it the one that I'm just used to. I'm going to put a dot anywhere on the outside. I'm going to open up my compass just so that it fits to this dot here. And then I'm going to go around with the point first on this dot. I'm going to do a little arc. And then I'm going to come around and do another little arc, and come around and do another arc. So basically the point of the compass is always on the intersection of the arc and the circle. And then I draw the new point, and then I put the point on this intersection, and the new arc goes below. And I keep going around, and I keep drawing this until I'm all the way back at the start. And then once I've done this, if I connect up all of these intersections, then I'm going to end up with a hexagon. I don't want that because we need an equilateral triangle. So what we're doing is we're skipping every second one. And this is going to get us where we need to be. We skip every second one. And there we go. Hope you followed that. There's lots of other videos on YouTube. I'll try and put some out as well just on construction soon. But leave all construction marks. That's very important. So everything in orange here you should have on your page in pencil. Okay, so that's question 26. Here's 27. So we're told to find the distance across a pond from B to C. A surveyor drew this diagram. The measurements he made are indicated on the diagram. Use the surveyor's information to determine and state the distance from B to C. So this is probably something to do with parallel lines and similar triangles. So let's separate these two triangles. We've got this one here, which is the smaller. We know that's 90, so this is A to D to E, and this is 230. And then we've got the bigger one, which is also 90 here. So therefore, these two must be parallel because they are perpendicular from the same line. And so corresponding angles here are both 90. They're congruent, so the lines themselves must be parallel. So anyways, let's keep writing. This is 120. We need to find the distance from B to C to the nearest yard. We know angle A is congruent to angle A. And we need BC, so I'm going to call that X. And this whole distance from A to C is going to be the result when we add both of these. So 230 plus 85 equals 315. So that 315 is going to be the length from A to C, 315. So maybe you see it now that we can set up a proportion. We've got 120 corresponds with X, so 120 over X equals 230 over 315. Now to find X, we cross multiply. So actually, let me get rid of those. So I got 120 times by 315 equals 230. X, divide both by 230. Now these 230s cancel. We could also cancel the two zeros here. That might be useful. So now I'm going to plug this into my calculator. X equals 12 times 315, and then divide all of that by 23. That gives me an answer of 164. And it says the nearest yard, so 164 is the nearest yard. And I should make my answer really clear, that BC equals 164 yards. That's my answer for 27. Okay, so here's 28. We're asked to prove that ACD, A to C to D, and we're talking about this angle. We're trying to prove that angle is congruent to CAB, C to A to B. Alright, well, if these two lines are parallel, DC and AB, then we know that these two angles are alternate interior. They have to be the same. So anyways, it wants us to prove. We could do a paragraph proof or a flowchart proof. I'm going to stick to the two columns. Kind of makes it more convenient for me. Harder to forget stuff. So this is where we make our statements. This is where we give our reasons. So we always give a reason for every statement. So the first thing is that we're told is that in parallelogram, I guess ABCD is a parallelogram. ABCD is a parallelogram. The reason is given. And also, we could add to this that diagonals, because this was also given, diagonals AC and BD intersect at E, point E. So I'm just going to leave that in there. Okay, next thing that we know, because we're told that this is a parallelogram, we know that DC is parallel to AB. That's one fact of a parallelogram. And we also know that this one here and this one here, we know that those sides are parallel as well. So segment AD is parallel to segment BC. And the reason for that is opposite sides of a parallelogram are parallel. So that was number 3. If opposite sides are parallel, we can then say, well, angle ACD is congruent to angle CAB. Notice that I'm using their exact language here. And the reason for that is if two parallel lines are cut by a transversal, alternate interior angles are congruent. So that's it. That's a complete proof, a 3-step proof for question 28. Here's 29. In this question it says triangles RST and also XYZ are drawn. If RS is 6 and ST is 14, and XY is 9, and YZ is 21, and angle S and Y are the same. It says, is RST similar to this? And then also justify. So we've got a side, an angle between another side. Side, angle, side. And that's one of the postulates for similarity. Now the angles have to be congruent, which they are. We're told that. But we need to prove that the sides are in the same ratio. So this comes down to matching up these sides. So it says, is RST, so RST, so RS is 6, similar to XYZ, so XY is 9, so we're matching those two up, and then the question is, does it equal, as a proportion, does that equal the 14, which is ST, over the YZ, which is 21. So if you look at this, 6 over 9 does become 2/3 if you divide by 3. 14 over 21 becomes 2/3 when you divide by 7. So they are in the same proportion. So yes, triangle RST is similar to triangle XYZ because sides are in the same ratio, or you can say proportional, and the included angle is congruent. And I guess you could say also by side angle side postulate for similarity. That would also be sufficient. Okay, so here's 30. It says in the diagram below, triangle ABC and XYZ are graphed using the properties of rigid motions. So when you think rigid motion, you think rotation, you think reflection, and the third and final one is translation. You must not think dilation. Dilation is not a rigid motion. It does not preserve distance. And it says use properties of rigid motions to explain why ABC triangle is congruent to XYZ. So ABC, XYZ. So if we rotate this shape, ABC, by 90 degrees around the origin, it maps it directly onto this. So we can say triangle ABC is congruent to triangle XYZ because when you rotate triangle ABC, in fact it's not 90 degrees, it's 180 degrees. 180 degrees, because 90 would just shift it by one quadrant, but we're going 2. If you rotate it 180 degrees, now it doesn't matter if we say clockwise or counterclockwise, it's ending up in the same place. You will see distance is preserved. And I would say that rotation is a rigid motion. So not only is distance preserved, but also, and all points A, B, and C are mapped to X, Y, Z. And I think that pretty much covers it. Alright, so here is question number 31. It says the endpoints of DEF are this and this. Oh gosh. Alright, so we've got to do a little work here. So I've got to grab this thing, the line. I'm going to do a quick sketch. It's got this and this. The first point that they are talking about is D, which is at 1, 4. So let's put 1 here, and let's say 4 is here. This is point D at 1, 4. The next one, F, is all the way out here at 16, and all the way up here 14. So let's just put it over there. F is at 16, 14. Now we can draw a line between them. It would look something like this. And the next thing that we're told is that there is a point somewhere here called point E, and E lives somewhere on here, I'm not sure, somewhere on this line, such that D to E is a ratio of 2 to 3. When we're talking D to E, this is 2 jumps and this is 3 jumps. So I guess the total, you could say there's 5 parts, and this is 2 parts as close to D and 3 parts as close to F. So in order to do this, if you had a grid, you could make these steps, and you could make 5 steps and then jump up 2 of them. But if we don't have that, one method that we can use is to draw this, to complete this, to make it a right triangle. So we've got this over here, and then we've also got going straight down. So in this right triangle, if we consider 1 through 16, now 1 through 16 gives us 15 units, right? 16 minus that 1 gives us 15 units. And then going up, we go from 4 to 14, so that gives us 10 units. So if we're dealing with 5 parts, what we can do is think, well, 15 divided by 5 equals 3 units per part. So therefore, if we've got to go 2 units from D to E, then we're going to jump 2 parts where each part is worth 3. So really we are adding 6, because each part is worth 3 units, and we've got to go 2 parts away. So if we add 6, we get to 7. So that is found as our X value of this. Now the same again, if this is 10 units and we have 5 parts, so we could say divide by 5, and that gives us 2 units per part. 2 units per part. So what we've got to do is go up 2 parts. So 1, 2, and then read across. So going up 2, if it's 2 units per part, then this is really like plus 4. So we got a plus 4, 2, 4. So this gets us to 8. So our point E is at the coordinates of 7, 8. And if you had a grid and you actually plotted these points, you could probably make steps like this, 5 of them, to work perfectly between them, and you could figure out 2 points is 1, 2 is right here. So that could possibly be a much quicker way to answer question 31. Okay, so this is question 32. This is from part 3. And so we're told a few things. We're told, as shown in the diagram below, a ship is heading directly towards a lighthouse, so it's heading this direction. We're also told that the beacon is 125 feet above sea level. At first sighting, at point A, the angle of elevation is 7. So 7 is this distance, this angle rather, up here. And then at the second sighting, a short time later, at point D, the angle of elevation is 16. So he's determined to the nearest foot and determine and state how far the ship traveled from A to D. So let's call that X. X is how far it traveled between them. So basically, if I separate these two triangles, we've got the long distance, which makes a right triangle. This is B, this is C, this is 125. This angle here is 7 degrees, and this is A. So let's call this a bigger distance M. So M is everything. Then a short time later, he arrives at D. So D is here. This is 16 degrees. This is 125. And let's call this N, the base here. So basically, we're trying to find X, which really, if you think about it, X is the result of taking the whole distance, which is M, and subtracting the shorter distance, which is N. So X equals M minus N. So our game plan right now is to find out M, find out N, and do the subtraction. So I'm going to change color, and first thing I'm going to write is SOHCAHTOA, because this might help us. So in the case of M, we've got an angle of 7 degrees, we've got the opposite, and we need the adjacent. So we've got tan 7 equals 125 all over m, which we can get m on its own by doing the little switch, which is mathematically means timesing by m to both sides and dividing by tan 7. Or we can do it the quick way, just switch them. And then for n, well, we've got this being 16 degrees, and then the opposite and the adjacent. So we've got tan of 16 equals 125 all over n, and then n equals 125 all over tan 16. So to find the distance x, what we're going to do now, I'm going to change color once again, make it a little clearer. We're going to take m, which is 125, divided by tan 7. We're going to subtract 125 divided by tan 16. So we can one-shot this in a calculator, just be careful with parentheses, but we have 125 divided by tan 7, close it up, and then subtract 125 divided by tan 16. And the answer I get is 582, and it does say to the nearest foot, so I don't need to round it beyond then. It's just 582 feet, and that's my answer. Okay, here's question 33. So it says a triangle ABC has these vertices. So this one I'm not so sure about, but I know the y value is 3. So let me just do a dotted line here. So I know that the y value is 3, but A lives somewhere on this line. We're not sure what the x value is. We also know that B is -3, -3, -1. So this is B. We also know C is at -1, -4. So that's C. And A is somewhere up here. So it says, determine and state the value for x that would make the triangle ABC a right triangle, and justify why ABC is a right triangle. So basically, let me complete one side here of this shape. BC is one leg of a right triangle. Now, we could go either straight up here to a point, and then if this makes 90 degrees, the two red lines, then that would be a right triangle. Or we could try and think of elsewhere for it to go, but it's going to cross over here. It's going to get a little messy. So it's probably going to be over here somewhere. So one thing that we can do is, when we're thinking about things that make 90 degrees, on a coordinate plane, we're thinking about things that are perpendicular. And perpendicular segments have the negative reciprocal slope. So if we find the slope of BC, we're going to have the rise, which currently looks like it went down 1, 2, 3, -3, all over the run, which is 2. So from C to A, so let's call it CA, the slope of CA must be the negative reciprocal of this. So what we're going to do is we're going to turn this upside down, so it becomes 2 over -3, and then it's the negative reciprocal. So that happens. So now we know the slope of this one, negative and negative cancel, slopes become 2 over 3. So that means there's a rise of 2. So I'm going to go back to C, a rise of 2, and a run of 3. 1, 2, 3. A rise of 2, 1, 2, and a run of 3. So I could keep doing this, or I could just grab this and draw this up. But basically we can now see where this third point has to be, because it has to live on this line. And so we now see that A lives right here, which is at 1, 2, 3, 4, 5, 6, 7, 8, 9. A is at 9, 3. And so that is our answer. And I can, when it says justify, we probably need to write a little more. So we could say that segment BC is perpendicular to segment CA due to negative reciprocal slope, and two perpendicular segments in a triangle make a right triangle. So that's something that maybe is useful to put as well. So that was number 33. Okay, so here's 34. This is the last question in part 3. So it says in the diagram below, AC and DF are congruent, which they've labeled. Also, ACD, and F are collinear on line L, so they all live on line L. It says let DEF prime, D prime, E prime, F prime be the image of DEF after a translation along the line such that D, point D here, is mapped onto point A. And then it says determine and state the location of F prime. Well, if we move this whole shape here, if we move this whole shape up, then D prime is going to be right on top of A. E prime is going to be up here. And F prime, terrible drawing. So I'm going to go grab my little arrow, straight line. So now we know that F prime is going to be where C is. So this whole shape moved up. So it says determine and state the location of F prime. So F prime would be mapped to C because AC equals DF. So when D maps to A, F must map to C. Okay, next it says let D double prime, E double prime, F double prime be the image of D prime, E prime, F prime after a reflection across line L. Suppose that E double prime is located at B. Well, that is actually what would happen. If this is reflected, E double prime goes here, D double prime stays in the same place, and C, not C, it's called F, so this is F double prime stays in the same place at C. So it says, is DEF congruent to ABC? So we can now say that triangle DEF, which is the original, is congruent to triangle ABC because through two transformations, all points are mapped onto a new shape and the transformations didn't include a dilation. Therefore, only rigid motions where distance is preserved. So just trying to get a few of these keywords, these buzzwords in, are really going to help you. So that was question number 34. Alright, that's the end of part 3. This is part 4 right now. 2 questions left. Question number 35 is asking us to prove that this is a rhombus. Okay, so this is a pretty big proof question. We're given that this is a parallelogram, we're given a few other things, but then we're asked to prove that this is in fact a rhombus. So you could do it in different ways, paragraph proof or flowchart proof. I'm going to stick to statement reason proofs because it helps keep me guided and gives me an opportunity to remember what I've learned so much of throughout the year. So statement and reason. So the first thing is A, B, C, D is a parallelogram, and the reason for that is given. Now we could also add a few other things in here. We could add that BE segment is perpendicular to CED. So BE is perpendicular to CED, so that's saying that this is 90. we can also add that DF is perpendicular to BFC. DF, BFC, so this is also 90 degrees. And then also CE is congruent to CF. So CE right here is congruent to CF. So this is a little tricky to see, but let me just draw this out here. That we have a situation where we have a triangle that looks like it is a right triangle right here, and then also we have another triangle goes here and drops down, and then here, and then if I draw all over this, this is a situation that we have. This triangle is BCE, and this one is FCD, and we know FC and EC are congruent. We know that this is 90 and this is 90, and we know they both share angle C. So we already know that these two triangles are in fact congruent by angle side angle, but we need to fit this into our proof over here. And once we know that those are congruent, maybe that's going to lead us to be able to say something about a rhombus, which really the main difference between a parallelogram and a rhombus is that all sides are congruent. Alright, so we listed number one. Now number two, so at this point we can put that the measure of angle BEC equals 90 degrees. We can also put the measure of angle DFC equals 90 degrees. And the reason for this would be definition of perpendicular, and they tell us perpendicular in one of the givens. The next thing we can do is say that angle BEC is congruent. So BEC, we're talking about this one right here, is congruent to angle DFC, and the reason for that is all right angles are congruent. So we know that. So far we've got this angle and this angle. Next, we already have CE, C to E, and C to F as being the same side. So that's one of our sides, and we just made an angle statement. So we're almost there. We now just need to say that angle C is congruent to angle C. So for angle C is congruent to angle C, and the reason is the reflexive property. And so that gives us angle side angle, so we can now make that statement that triangle BEC is congruent to triangle DFC, and the reason for that is by angle side angle. Now if we know these two things to be congruent, we now know that this side here, let me use bright blue, we now know that this side here, BC, must be congruent to DC. So let me make that statement. BC must be congruent to DC, and the reason for that is corresponding parts of congruent triangles are congruent. And what we just did is we said this side up here is the same as this side here. So now that we know that BC and DC are the same, we can go to our final step, which is really to say that ABCD is a rhombus, and the reason for that is that consecutive, meaning one after the other, consecutive sides of a parallelogram mean it is a rhombus. And so that is proof enough. That was question number 35. Okay, so this is 35 was a 6-point question. 36 is also a 6-point question. Really, really important ones. But often there's several parts to these questions. So we're going to go very slowly through it and surely through it. So Walter wants to make 100 candles in the shape of a cone. So he wants them in the shape of a cone. So that's the white space within the cylinder for his new business. The mold shown below will be used to make the candles. Each mold will have a height of 8. So that's saying that the height, which we could label outside or we could label inside, goes all the way down to the bottom, is 8. So all of this distance on the outside is also 8 inches. It says, and a diameter of 3, so that means that the radius is 1.5, just dividing by 2. To the nearest cubic inch, what will be the total volume of 100 candles? Well, the volume of one candle in the shape of a cone is going to be 1/3 base area times height. Now 1/3 stays as 1/3. The base is a circle, so the area of that is pi times r squared, and r is 1.5 squared times the height, which is 8. Now after I calculate that, I've got to times it by 100, and that gives me the number for 100 candles. Because we start with inches, our volume is going to be cubic inches, or inches cubed. So now I'm going to grab a calculator and type all of this stuff in. So I'm doing 1 divided by 3 in parentheses for my 1/3, and then times pi, and then times 1.5 to the second power, and then times that by 8, and press equals. So I'm getting an error on my calculator, so I've got to be a little careful. So maybe instead of doing 1/3 times pi, I can just do pi divided by 3, get that answer, and then times by 1.5 squared, and get that answer, and then times by 8, get that answer, and then times by 100, which gives me 1884. So maybe my error before was not putting a parenthesis in the right place. Now this does say to the nearest cubic inch, so 1884.95, and then goes on 55. So this needs to be rounded to the nearest cubic inch, so I'm going to go 1885 inches cubed. That's going to be my answer for the first part. Now it says that Walter goes to a hobby store to buy the wax for his candles. The wax costs this much per ounce. And it says, so let me actually bring that out. So this is 0.10, so that's 10 cents per ounce. That's how much it costs for the wax. It says if the weight of the wax is 0.52 ounces per inch cube, how much will it cost him to buy the wax for 100 candles? Well, 100 candles, we already have the volume. The volume equals 1885. Plus it's a decimal on my calculator, some change, but this is a total volume in inches cubed. So what I need to do to find the weight of this is take that volume and times it by 0.52. So using the decimal that's on my calculator, not the rounded answer, when I times that by 0.52, I now get an answer of 980.18 if I round it a little, and that's ounces. So using the volume, we multiplied by the ounces per inch cubed, and then this is how many ounces. And if it costs 10 cents for each of that, we're going to take that number and times by 0.1, which is the same as timesing by 0.10. And if you do this on the calculator, you'll see that the decimal is just going to jump 1 to the left. Times by 0.1, it's going to jump 1 to the left, acting almost like dividing by 10. And that's what timesing by 0.1 or 1/10, which is what it is. That's what it does. So therefore, this gives me an answer in dollars of $98. And let's just check how much will it cost. So I guess we've got to round this to 100. So it's $98.02. This should be 0.176, so it rounds to this. And they didn't ask to round it to any particular number, but because we do dollars and pennies, it should probably be to the hundreds. Next, it says if Walter spent a total of $37.83 for the molds and charges $1.95 for each candle, what is Walter's profit after selling 100 candles? Well, we know that his cost for 100 candles is going to equal the cost of the wax, which is the 98.02. So this is the wax. And then also the molds are going to be 37.83 for the mold. So these are his total cost, T cost. So I'm going to add those two together, 37.83. I'm still keeping my decimal on the calculator. So this gives me a total cost of $135.85. Now it's rounded slightly. It should be 0.84769. So I rounded that a little. Now his profit, if he's selling them, if his profit is going to be whatever he sells them for minus this cost. So if he's selling them for $195 each times by 100, that means his income is going to be $195. Now income isn't the same as profit. That's how much money goes in, and this is how much money goes out. So for his profit, we basically have to do the 195 and subtract the 135.85, and that gives us his profit. So in this case, we're gonna do this subtraction right now, and I've got a long decimal because I've kept the accurate numbers in there, but this gives me an answer of 59.15. $59.15, and that's the end of question 36 and of this Regents exam.